Hey guys, welcome back to the channel. I have another interesting video. This time I'm checking actually a 2008 Mini Cooper S. This is an R56 coming from Georgia. I have the customer paper in there, but it has all the personal information. So I have already in the screen that I'm using a little tripod as a stick so I don't have to be that close of that capture that you're seeing on the left corner. So the customer concern, and that is a picture of the computer that you can see here as well. And I have everything connected, ready to go. I'm using the Autel this time, even though I've done, and I connected it first, it did perfectly, no issues with that, and it's not really a bi-directional control for what I need, but let me show you this. So it's a little hard to read his writing, but what it says is in there, it says no ground to DME relay, and that is the only concern. Again, his name is Marcus Warren from East Dublin, East Dublin, Georgia. And the module has been here for a couple of days. I have the DME relay location and pinouts, so you can see that the relay that I'm using in here is a B&W original relay. It's exactly the relay that this vehicle uses. And the pinouts on the relay are different than what you will see on a regular relay, let's say for a domestic or Asian vehicle. And just to explain you, usually in here on this pin, you have terminal 30, but B&W moved for some reason terminal 30 over that way. And terminal 30 is constant battery power. 85 is the ground control coming from the computer, and 86 is a constant power. 87 is 87 and 87A, which 87A is constantly closed contact, which means it's always on even when the relay is off, and that will provide power from terminal 30 to 87A. In this case, that's not used. There's only 4 pins on this relay, but and it uses terminal 87. So when the relay is commanded on, it will close the contact, and then terminal 30 will send power through terminal 87, which I have in here, a test slide, so we can see from the distance when that happens, if it happens, and it has not happened. So I also have the wire diagram specifically for the car, where we can see the activation for the relay is in pin 28, and that is in connector X60004. The X6004 on this computer is the first one. You have 2 big connectors, and then a small one is the first one next to the big connector on the, it's one on the side, big connector. And just to show you, I have that pin 28. Hopefully you can see it because I have a little bracket on my way that I cannot see completely the screen, but I know that you guys probably seeing that. And that is, again, the ground side control going over the relay, and the rest is as I just explained you the connections. So just to show you the last digits on the VIN number, TT67719. That is actually also on the sticker. This is the original computer from B&W Mini Cooper, and they put always a sticker with the last 7 digits, and you can see TT67719. So that is perfect. And I was actually trying to see if any bidirectional control, because even though the DME needs those power, because the 87, if we see in this diagram, we have what the computer power supply is. This is the voltage supply for the computer, and also communication, because we got the wake up and the PT can in here, which is for the communications. All these brown wires in here are grounds, and then we have the reds as powers. They're all supply for this computer. Well, very important to understand when you're reading the original wire diagrams from Mini Cooper or B&W, and they put these things like N18 and N18, or sorry, N18 or not N18. So this is an N12. N12 will be not N18, so we need to have power on 5 and not on 29. The rest stays the same. So that's the only change that will happen if you have not N18. Same thing goes for the grounds, and mostly for locations, because the grounds are populated the same way. You see 3 grounds in here, but only on Mini R50. This is an R56, and it says 5X because it's all the 5 series. And only on Mini R6 series or 60 series, right? Then locations will change, right? So it will be ground X167, 167, and 167, and the other one is X151. They're all the same, but that's it. So I have all those in there, and what I was going to tell you, the main and the most important powers for the computer will be the one to turn the computer on realistically is this 7.5 amp fuse. It's a small, that's just to keep the computer alive, let's say. So if you disconnect these powers right here, even though they're for the computers to stay on, and those are, again, you can see this is the relay K6300, which is the DME relay, the one I was just showing you before. Even if this relay is not commented on and you have the ignition on and the wake up call, the computer will come on. It will not let the coils and other things work, but the computer will work. I cannot really reproduce that here because I have created a harness and I cannot unplug those powers. But I have done that on the vehicle, and it talked for a little bit, and it goes to sleep because you have to cycle the key because it doesn't see the DME relay working properly. And that's pretty much his concern on Marcus. So I was trying to, again, with the scanner, go into like an active test to see if it was a DME relay actuation, and it's not. It's very limited. Even if I go to general, the only thing I can command on and off is the fan, the fuel pump, only with the engine off, and the solenoid for the tank ventilation. Fuel injectors, you can see in that reset of the control unit is to reset the DME for faults or so. I was onto the data to see if we have anything. I even went into interfaces. All you can see is the starter activation, which is terminal 50, and then positions of that. So nothing about the relay on or off. And I even went into voltage supply. You can see it's already blue because I was here. And it's just a voltage supply in the terminal 15 on, which it is on. So, and nothing I can do with the scanner. So I wanted to show you that. So the only thing I can do, let me move the scanner out of the way here, 1 second. It will be to cycle the ignition. So if I cycle the ignition, the computer should go to sleep. And we can see in here that now the scanner is still reading, even though I turned the ignition off. And it says that terminal 15 is inactive. If I turn it on, this way you see it went over to active. So the computer doesn't go to sleep instantly. So it will lose communication. So if we stay here, even though right now terminal 15 says it's off, the computer is still talking to the scanner. So if we wait a little bit, that will shortly, probably in between 60 seconds, sometimes 20 to 60 seconds, the DME should go to sleep. But that relay should be always already on. So we are definitely already reproducing the concern. The only thing that I'm trying to do, and I can shorten the time for the video, which is pretty simple for me to do, which will be kill the power on terminal 30. So right now, I'm not even sure how the scanner is talking. Let me just try to see why it's not showing that there's no communication. You see, it's already no communication. Well, actually, it's kind of weird. Yeah, see, it's pass no fault. So a glitch on this scanner for that because there is no power being sent to the computer right now at all. And we can see that because I have also my multimeter, my bench multimeter connected to the sensor ground and sensor power. And that's also another way that you can see when the computer goes to sleep. But let's do the test. So I'm going to, I'm not sure if I can get this a little closer. Yes, you can see it in there. So I'm going to turn terminal 30 on and then ignition. And you see no reaction on the relay. That's exactly what his concern is, and we can definitely reproduce it. And look at now the 5-volt reference. So 5-volt reference and sensor ground and good communication from the computer are there. Again, let me turn the ignition off, keeping the battery on, and let's wait to see how long it takes that 5-volt reference to go down. Because that will be a clue immediately when the computer goes to sleep. 12:41, it's almost 1 p.m. and I haven't even ordered lunch. I get too concentrated on the repairs and tests that sometimes I forget about eating. But I do. I mean, like, I eat, but it's later than I should, and that's not good because you can get, ulcers from, from your stomach just growling. But I guess so far I don't feel that. I'm surprised it's taking that long for that five-board reference to go there. So to not hold you in the video, but this is something you can check. You can put a multimeter in your vehicle's five-board reference, and then you can find out when the vehicle went to sleep. If you are doing something that you require to check the vehicle from going to sleep or not. All right, guys, let me open the computer, and I'll be right back. I'm actually using my phone. I'm kind of like liking the resolution of the camera on the iPhone 17 Pro Max and the availability to put this square box in there so you guys can see what I'm doing. All right, so let me, like I said, let me stop the video 1 second and let me open the DME to see what we find, right? All right, let me move this over a little farther so I can get this away from me. All right, so guys, as you see, I have the computer completely open. I already repaired it. So, but I'm going to show you what the damage was. And this computer was this close to not be able to be repaired. That is just so you can see. That is the case of his computer, completely removed from the, the board from the case. And this was the damage. So, capacitor leaking. But this created a cascade of problems. I have to replace so many components, clean the board. I actually give it a bath on the ultrasound for 3 times in order to remove the acid. Let me show you. This is the other side of the board, the one we're facing now. And these are the capacitors. They're hydrolytic capacitors. They're very prone to leak. These are 2008, so almost 20 years old. And as you see, these capacitors are not meant to last that long. So they make it on purpose, right? So you go off a warranty and now it's your own problem. So if you have any Mini Cooper, 2006, 2007, 8, and I would recommend 2010s and so on, just send it over before it's too late. And I will do what I call a refresh, which is with no concerns, just repairing the computer, replacing the majority of the components that I do, which is ignition coils, injector drivers, capacitors, and diodes. And you will have another computer good for 25 years, 20 years. So that's it. And yeah, these components are now lasting what they should. But yeah, so these are the hydrolytic capacitors right in the other side, exactly where I was showing you. And this is a closed section, so you can see the leak. The problem with these leaks is this car, multi-layer boards. So these can go under it, and it did. You see how here and here, here, all this is covered by the acid, even though it was leaking right here. And that goes through the other side of the board, as I showed you in the beginning. This is the other side of the board. You see this is where the microprocessor is. Let me flip this over. So that's that side of the board. And that goes through, and I have to replace all these little components. I replaced the CAN transceiver and voltage regulator because it was also corroded due to the acid, and that's a problem. And also the CAN transceiver in other areas in the board that were affected. But yeah, so let's do the test. I have the scanner connected, and I'm using it with TeamViewer. One thing that we will see immediately, remember I have the actual power on just to power up the BCDI from top down, which again I'm using it through TeamViewer. And this is only going to be just to read the being number, make sure that everything is reading properly. The computer is off. You can see no fiber reference. It actually took almost 10 minutes for the 5 volts to disappear. So the computer takes like almost 10 minutes to go to sleep on this vehicle. All right, so let me power this on. So ignition, and we got the main power relay. Remember, that was not on. That wasn't working. Remember, all the connections are the same. Pin 28 going over to terminal 85. And then 86 is power. I got terminal 30 supplying power. And then 87, I have this test light connected and then supplying ground on the other side. So everything, the circuit is now complete and operational. All right, so let's see if we read the big number. Remember, the last digits are here. TT67719. These I have not done, so this will be after repairs. Same with you to watch this working. Okay, I like that sound. Yes, 2008.8. And we have right there TT67719. So perfect. We got good communication. The computer was actually talking. It's going to take a little time to go through the entire submenus, and it tries to establish communication with the entire car. But I think that in this, the top down is actually faster than the uh, Hotel. Hotel, like the Ultra that I have, is because it goes over almost like original BMW factory scan tool. And that's why it takes that long, because it's going through like the test plans, like BMWs and Mini Cooper, when they connect to the original scanner, is go ISTA, right? ISTA next. When you connect to that, it's not just communicating with the car, it's actually doing some pre-test plans or pre-tests to see how the network communications and everything goes. So that's the same thing the Autel does. Actually, I changed the bracket that I'm using to see my phone, and now there's nothing in my way. It's a magnetic uh, holder, perfect, and it grabs the MagSafe for the charging. It's very good because I can see through and everything is perfect. Let me see if I'm going to just do a test. Oh yes, I can move the position of that even while I'm recording. So if it's in the way, I can move my little window in there so it's not going to be in the way of you. But yeah, so we are here. We're going to do a manual selection because we don't have the entire vehicle. So this is a Mini Cooper. And all these are covered onto this connection. We're going to go, this is an R56. We're going to drive, and then the ECM, which is realistically called by Mercedes and, sorry, BMW Mini Cooper, DME, Digital Motor Electronics. That's what those letters stand on for. And we see the same information being correct. We're going to do, just to read the data stream, I'm going to go over to the, let me see, voltage supply, because I have nothing connected. And I'm going to just to make sure the communications are proper. Let's just wait to that to go over. Okay, so we are here now. And let me put this one in a graph. So I'm going to change on my voltage supply. I can select the voltage and I can go 1 volt up or down. So let's see that graph. I'm going 1 volt up, and it did. I'm going to go again to where the battery voltage was. One down, one up. And I can definitely see the changes even on the voltage. You see that, look at that, it goes dimmer and brighter when I adjust the voltage, as I am doing now. So right now it's in 13.5, which is usually what Mini Cooper uses when the vehicle is running, like around 13.5, 14 volts. It depends on the charging system, but that's a normal battery voltage for these vehicles. Anything above 12.6 is considered normal. You'd like to keep it around there. Yeah, 12.6 is a little low. So let me just go back to where I was. But yeah, I guess you can see the changes of the communication in between the scanner and the computer. Everything is working well. We got sensor ground and sensor voltage. So your computer, I forgot his name. Let me just read it from the note. I think it's Marcus from Georgia. Your computer is ready to go. I'm going to put these two videos together because for some reason the video stopped. I think I had the phone uh, going to sleep. Now as I set it up as never, especially if I recorded videos, and I remind myself to put the no call like that. I don't get stop the video because somebody calls me. All right, guys, thank you so much for visiting the channel. Let me know what you think about this video quality, the audio. I'm actually recording right now with the Apple AirPods Pro 3, and they seem to sound really good. At least I've been watching two videos that I did, and they sound really good. I don't have to increase my volume or anything. And I think the resolution on this iPhone 17 Pro Max is actually really, really good. So for little things like this, I don't have to use the auto setup, or I can do it in conjunction. That's up to me, or yeah, up to me. But let me know what you think, all right? Guys, see you next time. Bye-bye. Don't forget to subscribe.